All right, so CloudFormation allows you to import existing resources into a stack. And this is a great feature, but when you combine it with the abstractions that the CDK provides, you can find yourself in some hard to solve situations. And we recently ran across one of these scenarios and I wanted to share it with you. Now, if you'd rather read a blog post, I'll include one in the description of this video. While this is a real scenario we recently ran across at Defiance Digital, I've changed a few of the insignificant details to protect the innocent. So the problem is, a production environment needed a quick restoration of a database to get the system back up and running. And while this could and should have been done with the CDK, it wasn't at the time, and the RDS instance was created manually from a snapshot. And this was a one-off situation, and the team was under pressure to get the system back up and running. While we had the RDS instance up and running, we needed to import it into the CDK stack so that it could be managed through our normal IAC pipelines. And we had a couple of choices. One, we could retain and delete the old RDS instance from the CDK code, add it back in and use the CloudFormation's import to tie the new RDS resource to the manually created instance. Or option two, add a new CDK resource that would represent the manually created RDS instance and import it into the stack. Now, option one wasn't really a good option. In this case, we'd have to also delete all the supporting resources and re-import them. If there were any complications along the way, we could end up in a worse situation than when we started. So option two felt like the safer choice. We could add a new CDK resource that represented the RDS instance and import it into the stack. However, there was a catch. The RDS instance that was restored manually was using the same subnet group as the old instance. So now we have this. The original CDK RDS instance, L2, that defines the original CloudFormation RDS instance and the CloudFormation subnet group. And two, a new CDK RDS instance, L2, that defines the CloudFormation RDS instance and reuses the CloudFormation subnet group. Now we can't let it create its own subnet group because that would require a replacement of the RDS instance. With the CDK code set up, we can generate a template and then import the resources through CloudFormation. But a new problem happens when we later clean up the CDK code to remove the old RDS instance because that L2 also defines the subnet group. And then deleting the L2 will delete that subnet group. So what does the CDK construct for the new RDS instance use? Well, deleting the resource itself isn't a problem. The problem is that the CDK constructs are tied together in a way that deleting the CDK resource for the first RDS instance means we no longer have that subnet group for the second instance. We can let the subnet group get created by the second construct, representing the new RDS instance, but the logical IDs won't align and CloudFormation will see this as a replacement operation, and we clearly can't let that happen. So we resolve this by overriding the logical ID of the subnet group in the second CDK construct to match the logical ID of the first CDK's subnet group. And we're going to use my logical ID remapper aspect to get this done. Now, although the original subnet group is deleted, the new subnet group created will have the same logical ID, and CloudFormation will see this as a no-op. Of course, we need to make sure the CDK's subnet group that's created isn't materially different from the original, or else a replacement would be necessary, and requiring an instance replacement would defeat the purpose, but a subnet group is a very simple, trivial definition, so it shouldn't be too bad. So I'll recap all the steps that went into this. Number one, the CDK code already existed that defined an RDS instance and a subnet group. A new RDS instance was created manually outside of the CDK code that we wanted managed by the CDK code, and it used the same subnet group as the existing database. A new RDS instance was created in the CDK code, and it used the original construct's subnet group. And finally, CloudFormation imported the RDS instance into the stack. Now, at this point, we had a stable stack where we had two RDS instances properly managed through CloudFormation and the CDK code, and now we needed to clean up the original instance. We removed the original RDS instance CDK construct from the CDK code, and we remove the usage of the subnet group reference and allow the L2 construct to create a new subnet group. Then we override the logical ID of the subnet group in the L2 construct to match the original subnet group's logical ID, and then we diff and deploy. Rather complicated. Hopefully that all made sense. If you have any questions, please leave comments in the video, or you can reach out to me on Twitter. Hope this helps you sometime in the future. Thank you very much.